this isn't working. How would you do it? How would you solve this problem? How about I'll talk you through how I'd do it. Here I am. That's bad. I would run this program in a debugger. Do you know how to do that? If you don't, go practice until you do. I would then walk my Mario in until he's inside of the tube, because that's not supposed to happen, right? Then I'll go down to some place where I want to look at it. How about, what do we call get out of the tube? Right here. I'll put a breakpoint right about here in my code. This isn't even a debugger, but that's where I would put the breakpoint. And then as soon as I do, the debugger will stop at the code right here because Mario's inside of there. And now once my code is broken right here, and by broken I mean stopped, I will then step into does collide, which we'll call up to here, and then I'll check. Why is it returning true, or is it returning false? And I'll see what's happening. Now, presumably, it should return true, and that should, because it returns true, that should then call Mario get out of the tube, which should then push my Mario out of the tube.
We know it's returning true.
Is that happening?
How did Mario get in there?
Oh, that's a good point. It is. It is returning true because it's saying, how the heck did I get in here? Therefore, it's failing to push Mario out of the tube, isn't it? Okay? So then I would stop there and I would step into get out of the tube. That would go up here to get out of the tube, and I would step through and see why it isn't actually moving Mario out of the tube. And then I would find my problem and I would fix it. Do you want to do it? Do you believe that process will fix this problem? Well, it will. The short answer is anytime you have a problem, you need information. You need to know what's going on and why. Once you know what's going on and why, then you know how to solve the problem. If you don't know what's going on, the answer is you have to find out what's going on, and that's how you debug code. Any questions on that? Okay, I think I'm going to leave it at this point unless somebody calls out from the audience and says, please debug it. Okay, good. I guess you've heard enough of that. We could very well debug it, but you could also put it back. Let's talk about the next thing we need to do. So I'm going to come to my code and put it back into the state that I know is working. Okay, we are in a working state. Truthfully, I don't know why it wasn't working before, but if we ran it in the debugger, I could certainly find that out. Yes, you can. And in fact, the thing I did here is I changed his position, but I didn't actually change his velocity. Now, if we had velocity, well, the main reason I didn't do that is, look, no velocity, right? So I didn't even have a concept of velocity. Suppose you were writing a Mario version with ice, you know, the penguin level where Mario slides around on the ice. Then you'd need some kind of velocity because he doesn't just move, he kind of gets momentum and then slides around, right? When you hit a tube, you certainly want him to stop, don't you? What if there were tubes that go up and down or something like that? Isn't there a level like that? You wouldn't want it, once the tube goes down, Mario suddenly slides past again, right? You'd want him to have stopped. So if that were the case, I would have to modify my code to say something like xvel equals 0. And then that would do exactly what you're saying. Oh man, I pushed the CD tray again. I am truly getting fat. Okay. Next topic I want to cover is inheritance. Have you guys started working on assignment 4 yet? The main thing with assignment 4 is we're going to start making classes that inherit from each other, and then we're going to do something called polymorphism. I'll describe what polymorphism is in a minute when we get to it. But for starters, let's make another class. How about Goomba? Int x, int y. And we're going to want to draw this Goomba, so come down to my view. And you know what? I'm already running through all of the tubes. How about I'll say g.draw image. You know what? I'm not even going to do it the old way. Let's just start writing things the new way. So I've got a Goomba. And I'm going to draw a Goomba in a little while. But we need to architect our game so that now it can have tubes and Marios and Goombas. And This is getting a little bit hairy, isn't it? How can we do, how many Goombas can you have inside of your game? Depends however many you want. That should always be the answer, right? So we can have an array list of Goombas. And then we can come up to our view. And after we draw all the tubes, then we can draw all the Goombas. And after we, and down here in our model, when we do a model update, here we are updating all of the tubes. We've also got to then iterate through all the Goombas and update all the Goombas. And you can see what's happening. As we add more and more things to the game's getting more and more complex, and that's bad. Do you agree with that? We don't like complexity. So let's observe something. Goombas and Marios and tubes all have a few things in common, don't they? They all have an X and a Y position. They all have a width and a height. They all have an image that can be drawn to the screen. They all have a method named update, which we're calling 30 times a second that updates them. They all draw themselves. Wouldn't it be kind of nice if we could just write this code one time? Wouldn't it be kind of nice if we could just have one big list of, say, things rather than turtles and Goombas and Marios and all those things? And wouldn't it be nice if we could just make our engine just handle stuff and just update the stuff and draw the stuff? And it all works because they all have things in common. I think you'll agree that makes a lot more sense. So I'm going to make another class. I'm going to call it Sprite because that's what I say to use in the instructions. You could call it Tiddlywink if you want. It doesn't matter what it's called. It's just a name. And then I'm going to say Goomba extends Sprite. Mario extends Sprite. And Tube extends Sprite. What does extends do? Well, let's draw that graphically. Let's suppose this represents a sprite class, and a sprite class has a squiggle in it and a woobop in it. By squiggle and woobop, of course, I mean member variables, because this is an object on the heap, and that squiggle and the woobop represent some member variables that I've stuck in the sprite class. Now, if I make an instance of Mario, it actually looks kind of like this. And then inside the Mario class, there's the vertical velocity and whatever else a Mario has that's unique. And if I make a tube, it might look kind of like this. And a tube might have whatever tubes have, tubiness and tubular variable. These are the member variables of the tube class, and then the red ones I say are the member variables of the Mario class. And you know, there might be different numbers of them. The tubes might actually be smaller objects than the Mario objects. But do you see how they both still have things in common? So if I were to allocate 5 Marios, that might waste more memory than if I allocated 5 tubes. But both Marios and tubes have this portion of them in common, and this portion is actually what I'll call sprite, because Mario extends sprite and tube extends sprite. You get what extends does in memory? It basically makes the objects have the same portions in common. And so, is Mario a sprite? Yes. Is tube a sprite? Yes. Is some random sprite a tube? Maybe. Maybe not. Because it might be a Mario, right? Are you a human? Yes. Are all humans you? No. It's one of those is a type situations. So if the class extends another class, then we say that in fact tube is a sprite. It's not like tube is a different class from sprite. Tube extends sprite. It's an extension of sprite, as I drew right there. See how it extends it? Okay, so that's kind of what should go on in your head when we extend. Now, because Goombas and Marios both have an X and a Y, I'm just going to stick that in the sprite class, because that makes sense, and remove them from Goombas and Marios, and how about from tubes as well. And that's kind of nice, because now I don't have to worry about X and Y inside all of them. I made my objects a little smaller, a little simpler, and remember how the fewer member variables you have, the simpler your code's going to be, right? Well, the more I can handle things in sprite and do it in a common way, the more I'm never going to have to think about those again, and then I can focus my time on making my video game awesome instead of making my video game, make every new piece have all the functionality that I want to add. Now, it was kind of a pain to make Mario interact with tubes such that those tubes felt opaque, felt solid, and he didn't intersect with them, right? Think about how big of a pain it would be if you had to write this code for every pairwise combination. Can Marios intersect with Goombas? Can Marios intersect with tubes? Can tubes intersect with Goombas? And so on and so forth. Big pain, right? Wouldn't it be cool if we could just common code this thing so that sprites basically behaved like they were solid, and then we could just start adding stuff and wouldn't have to think about collisions ever again because we thought about it once and basically solved that problem forever? I think you agree there is power in inheritance. There's power in, in polymorphism, which I'm about to describe. So there are, however, cases where sometimes things need to be different. For example, Mario update. That's not really the same as tube update, right? What do tubes do when you update them? Well, nothing. In fact, we don't even have a tube update, do we? Nope, we don't even update tubes. But we could, because maybe in some future game, we'll have tubes that pop up and down because we have the silly music that makes it look like the tubes are dancing. You seen that version of Mario? There's one where the tubes bounce up and down. Okay. We certainly have to update the Goombas, right? Do we not? Because the Goombas have to walk back and forth, and so that means they're going to have to move, and when they intersect a tube, we're going to turn them around, so we probably have a Boolean moving right variable, and every time they hit a tube, we'll invert the value there, so it'll go left, and then they'll go right, and then they'll go left, and then they'll go right, or something like that. We're going to have an update here, but we can't really put update here, because if we did, then how would we write it? We could basically say, if I am a Goomba, do this, else if I am Mario, and do this, else if, but that's just a little bit ugly, isn't it? It's going to be cooler if we can leave the update inside of each method. So, introducing a new concept called abstract. I'm going to make the class abstract, and I'm going to make this method abstract. When you make a method abstract, you just put a semicolon on it and you don't give it a body. This is a body. Everything between here and there is the body. And if you don't, then it has no body. What is a method with no body? It's like the soul of a method or something like that. I don't even know what that means. But what it basically does is it says, hey, there is a method named abstract, named update, in every class that extends sprite. Does that make sense? And so, if Goomba extends sprite and fails to provide an update method, and I were to compile, the compiler would yell at me and say, hey, Goomba extends sprite, but it fails to implement this update method. Okay, so abstract basically means this method exists, but it doesn't exist. It means you can't actually allocate an instance of type sprite because it doesn't provide the update method. But you can allocate a Goomba or a Mario or a tube because those are all types of sprites and they all provide a corresponding update method, and then that will work. Does that all make sense? Okay. Well, let me pretend I didn't put abstract right there so I can create some bugs, and let's compile so we can see some compile errors and help you know what they all mean. Okay, so I'm going to build, and I'll get lots of errors. Apparently only one. Sprite is not abstract and does not override abstract method update in sprite. What do you suppose that error message means? I'll just tell you. It means hey, see there's this abstract method? That's like a contract. That means anything that extends sprite must implement that. Now, because Sprite doesn't implement that, and that's the whole point of Sprite, is to kind of provide a template for what a sprite is, I can't update it here, so I'm going to declare sprite abstract, which basically means thou shalt not instantiate this class. Abstract classes cannot be instantiated. Non-abstract classes, like Goomba, can be instantiated. Did you follow that? Okay. Let's build again. Now I get new error messages. Okay, error. Tube is not abstract and does not override abstract method update in Sprite. What do you think that means? There's no tube update. Okay, so we come down here to my tube class. Void update. Now, in fact, that's all I want the tube update method to do right now. Why? Because tubes don't really do anything. They just sit there. So that's a good way to do it. Pretty sure it's going to tell me the same thing for Goombas next. Goomba is not abstract. Yes, indeed. Okay. Goomba. Now it is. Now I build again. Wow, that was it? Okay. Apparently now I have working code. Let's see if it even works. I have no idea if it will. Game. Here I am. Mario runs. He still can't get in that tube. Looks like it still works. Okay.